Hello everyone. Today we are going to study about the pH of strong acids and basic solutions in this video. The objective of the lesson is to calculate the pH of strong acids and bases, ionic product of water, relationship between pOH and pH, limitations of formulae of pH, and in the end some numericals on pH of solution containing strong acids and bases. First of all, let us study what is pH. pH first of all was developed by Søren Sørensen. The meaning of pH is negative logarithm of hydrogen ion concentration. This formula is applicable for dilute solutions and for strong acids and bases. So pH may be defined as the power of hydrogen or the concentration of hydrogen ions in the liquid. Here is some of the substances and in the bracket their pH values are given. For example, tea has pH value of 5.5. Acid rain pH value is greater than 5. Healthy human saliva pH value is 6.5 to 7.4. Pure water, this pure water is very important. Pure water has pH value of 7. The solutions whose pH value is 7 are considered as the neutral. Similarly, battery acids has pH value of 0.5. Gastric juices in the stomach, beer, milk, blood. Blood has pH value in the range 7.34 to 7.45. Now, what is ionic product of water? Water, all of we know that it is a weak electrolyte, that is, it cannot conduct electricity. To make it a good conductor of electricity, we have to add some amount of acid or base in its solution. So water can be written as hydronium ion concentration and OH negative ions in the equilibrium, and the equilibrium constant for this reaction is concentration of products upon concentration of reactants raised to power 2. Since water behaves as a weak electrolyte, so its concentration in the solution will remain almost constant. So it can be cross multiplied with Kc to give ionic product of water Kw. So Kw is equal to the product of hydronium ion concentration and hydroxyl ion concentration, and the product of concentrations of two ions is 1.008 into 10 raised to minus 14 mole square per liter square at 25 degrees Celsius. This ionic product of water is useful to find out whether the solution is acidic or basic in nature. Let us see how. If hydrogen ion concentration, that is hydronium ion concentration in water, is greater than hydroxyl ion concentration, the solution will be acidic. And for neutral solutions, hydronium ion concentration, hydroxyl ion concentrations are equal, just like in pure water. for basic solutions, hydroxyl ion concentrations is higher. From the ionic product of water, we can find out a relationship between pH and pOH. Let us see how. Take logarithm on both sides of the above equation. Minus log Kw equal to minus log of hydronium ion concentration, hydroxyl ion concentration equal to minus logarithm minus 14 base to 10. So, in the last, pH plus pOH is equal to 14. It means if we know the pH of the solution, we can find out the pOH of the solution and vice versa. This relationship holds good for dilute solutions. It is the comparison of pH and pOH. If hydrogen ion concentration is from 1 to 10 raised to minus 7, the pH value comes out to be 0 to 7. And if hydrogen ion concentration is again less than hydronium ion concentration, it means hydroxyl ion concentration is more. The pH values are greater than 7. In the lower side, pOH values are given. The sum of two pH and pOH is always 14. 6 plus 8 equal to 14. 4 plus 10, 14. 2 plus 12 equal to 14. And so on. The mathematical formula for calculating the pH from the formula has certain limitations. For example, pH value is 0 for one normal solution of strong acids. pH value is negative for very concentrated solutions. It means pH equal to minus logarithm hydronium ion concentration is not applicable for strong acids and concentrated strong acids and concentrated strong bases. At higher concentrations, in place of pH, Hammett acidity functions are used. So here are some of the questions related to pH value that we will solve in the next video. Thank you.